Hi everyone, I am Fiona Label El Minoro, and today I will show you how to find an equation of the tangent line to the parabola y is equal to x squared plus 2x plus 1 at the point of 2, 9. So we have a given function which is f of x is equals to x squared plus 2x plus 1 at the given point of 2 and 9. So the values of a, b, and c come from the given function f of x equals to ax squared plus bx plus c. So our a is 1 because we know that a variable is equals to 1. So our b is from the 2x and our 1 is from the 1. So to find the vertex of the quadratic function, we use the formula negative b over 2a and 4ac minus b squared all over 4a. So since we have our function, let's substitute it. So for the negative b, we have negative 2 over 2 times 1. So if we are going to solve it, we were gonna get negative 1. So we have 4 times 1, which is our function a, and then function c is 1 minus our function b, which is 2 and then squared all over 4, and our function a again is 1. And if we are going to solve it, we will get 0. So now our vertex is negative 1 and 0. So now we create a table of values to help us draw the graph. So for each value of x in the table, we substitute it into the function. The given function, which is the f of x is equal to x squared plus 2x plus 1 to get the corresponding value of y. So whatever answer we get after substituting, that will be the y value in the table. So for example, if x is equal to negative 4, then we are going to substitute it to the function. So example, f of x is equal to negative 4 squared plus 2 times negative 4 plus 1 is equals to 9. So now we are going to repeat this process for all values of x to complete the table. Since we completed the table, we are going to plot it in the graph. So now we are going to plot all the points on the graph. And of course, after plotting the graph, connect the points to form a smooth parabola. So after plotting the graph, we are going to proceed to solve the slope. So to find the slope of tangent line, we use the limit definition or the limit process of derivative. So we are going to use this formula. M of x sub 1 is equal to limit as delta x approaches to 0 of f of x sub 1 plus delta x minus f of x sub 1 all over delta x. So now substitute the function. So note that our x from the function, the given function, is equivalent to x sub 1 plus delta x. And our delta x is the y. So now, this is what our function looks like after substituting everything. So next is we are going to expand our x plus delta x sub 1 squared. So we have now x squared plus 2x delta x plus delta x squared. So this is the expanded form of x sub 1 plus delta x squared. And then we are going to distribute the 2 to x sub 1 plus delta x. So now we are going to have a 2x sub 1 plus 2 delta x. And then we are going to copy the plus 1. So now we are going to multiply our negative sign to x squared and then the 2x and the 1. So we are going to have a negative x squared minus 2x minus 1 all over delta x. So now we are going to subtract the like terms. So we have x squared minus x squared is equal to 0. So we are going to cancel it out. Next is we have 2x sub 1 minus 2x sub 1. So we are going to cancel it out 2. So lastly, we have 1 minus 1, so equals to 0. So we are going to cancel out 2. So in this step, we are going to rewrite the remaining function. So now we have delta x plus delta x squared plus 2x sub 1 plus 2x delta x all over delta x. So now we are going to identify our function if we can factor out. So now we can factor it out using the delta x. Since we can divide the delta x from numerator and the delta x from the denominator, so we are going to cancel it out. So our function will be mx sub 1 is equals to limit as delta x approaches to 0 of delta x plus limit of delta x as approaches to 0 of 2x sub 1 plus limit as delta x approaches to 0 of 2. So every delta x in the function, we are going to substitute it to 0. So now we have 0 plus 2x sub 1 plus 2. So our m of x sub 1 is equals to 2x sub 1 plus 2. We are not yet done, so in this step we are going to solve the slope. So remember that our given point is 2 and 9. Our 2 is the x sub 1 and the 9 is our y sub 1. So we are going to substitute the x sub 1 to the function. And if we are going to solve it, our m or our slope is equal to 6. Since we already got our slope and we also have the given point, which is the x sub 1 and the y sub 1, we are going to solve for the tangent line. So we are going to use the point slope form, which is y minus y sub 1 is equals to m times x minus x sub 1. So remember, our given y sub 1 is equals to 9, our x sub 1 is equals to 2, and our slope is equals to 6. Now, since we all have our values, we are going to substitute it to its corresponding function. So, y minus 9 is equals to 6 times x minus 2.
2. So, we are going to expand it. So, we have y minus 9 is equals to 6x minus 12. Since we multiplied our 6 to x and the 6 to negative 2. So now we are going to transpose and combine. Going to combine the constant, which is the 9. Negative 9 plus 12 equals to 6x minus y. Then we are going to solve. So we have 3 equals to 6x minus y. So we are going to transpose our 3 to the right. So it will become 6x minus y minus 3 equals 0. So that is our tangent line. So now, since we've solved the value of m, which is our slope, and the tangent line, we are going to plot it all on the graph. Start at the point 2, 9, and then use the slope, which is the 6, which means rise is equals to 6 and run is the 1. This line touches the parabola at exactly 1 point, which is 2, 9. And that's it. That's how you find the tangent line step by step. So we determined the vertex, graphed the function, found the slope using limits, solved the tangent line, and plotted everything on the graph. So I hope you learned something from this video. Thank you for watching.